In this video, we'll be going quantum. So we'll be discussing a few things about very basic things about Qiskit, about how to initialize the quantum circuit, how to add gates, the various types of gates, and how to measure. So before we go into this, and also we will also see how the visualization happens. And one of the uh, functionalities that Qiskit provides us, and we will see how that happens and how we incorporate it with our project. And so okay. So before we proceed, anything quantum, any quantum circuit actually has three parts. That three actions that you need to undertake to work with a quantum circuit. The first state is the state preparation. So to it's not required. This part is not required in basic things that we are about to do. But if you're doing something like quantum machine learning, for example, then you need to encode your data, and this step is called state preparation. But for our case, we are just happy with the initial state that we get, which is zero ket. So we are okay with it. So the next step is applying gates. So in the second part, you apply all the gates that you want to, and according to your requirement and the operation that you are trying to do. So in the third part, you take the output using the measurement operation, and for this, you require classical bits, and usually these are the same as the number of quantum bits. So for one classical bit, so for one qubit, you have one classical bit. So let's see how it goes in Qiskit. First of all, from Qiskit, import quantum circuit. Again, you can use quantum registers to initialize uh, qubits and classical registers for classical bits, but I'm just doing it the easy way, I guess. You can explore it in the documentation of Qiskit. So say circuit is equal to the variable circuit, quantum circuit. This is the quantum circuit class, and we will give two arguments here. So I just want say one qubit and one classical bit. That's it. So now uh, we have our circuit ready. Now this circuit variable now denotes our quantum circuit. So now we can add gates to this because we don't need state preparation step here because we are doing something really basic stuff. So we can add circuit dot say x and 0. So 0 denotes the position. So since we have only one qubit, we give this value 0. It's just like the slicing in Python that we saw previously. So if we had two qubits and we wanted to do some operation on the second one, we would be giving the value 1 over here. So that's how it works. So let me just print this now. Print circuit. And now I can print. It will take some time, I guess, after that. So you can see here we have a qubit, Q0. We have this one classical bit that is denoted by this number 1. And we have applied this gate, the X gate, not gate, you can say. Now, let me show you another thing, circuit dot barrier. So barrier is just used to differentiate your various parts of the operation that you are doing. So you will be applying various gates to your quantum circuit, and all of them will be having specific purposes. So to accomplish one particular task, uh, you will apply a few gates, and you can use this barrier to differentiate this task from the next task that you will be doing on this quantum circuit. So it's just that. So if I run it again, you can see this line here, and this is the barrier. This is sort of a differentiator between your parts of a quantum circuit. Now, the most important part, circuit dot measure. And we can give 0, 0, which means that the 0th qubit will be measured and its value will be stored in the 0th classical bit, which again the 0th classical bit just means our bit that a classical bit that we initialized here. So it's simple. Okay, let's see. You can see this measurement operation here. So we have applied the X gate and we kept this barrier, and with this measure we just measured this qubit here and its value will be stored in this classical bit. Okay. Now another good thing that let me just clear this for visualization purposes. So from Qiskit dot visualization import visualize transition. So visualize transition will help us to visualize the transition. The pop-up window that you used to see when we click the button visualize, and that was nothing but this visualize transition. So it's that simple. So if I do this and I run it now, let's see what happens. You can see here window has popped up. It's hanging a little. My system is hanging a little. You can see, and it will end up here in 1. We know that. So this pop-up window that came up and this visualization of transition is this function visualize transition. And another key thing to note is that we can't keep measurement in the circuit, so we can visualize only before measurement. Because for measurement, after measurement, the state collapses and we have either one of the basic states. So that's why when you use this visualize transition, you need to use it before the measurement. Okay, so I think that's it for this video. It's a short video, I know, and I just tried to cover the most basic things that we would require while working on the project ahead. And I hope you like this. And in the next video, we will dive into the project again and we will code the functions for about button. I hope you too see you there.